In this video, we're going to take the derivative of e to the x. And I really do like the derivative of e to the x because it's just e to the x. And as with all of this, you shouldn't just take this at face value. When someone tells you this, you say, okay, why? So let's go through why. I'll show a proof next. If you want to skip the proof, there will be times in the description that you can click on to skip to the examples. So here's a little proof. So first, with the proof, we'll start off with the left-hand side, taking the derivative with respect to x of e to the x. And based on the definition of the derivative, I can write this as the limit, as h approaches 0, of e to the x plus h minus e to the x all over h. But I know by my exponent rules that e to the x plus h is e to the x times e to the h, and I have this minus e to the x all over h. And I see now in the numerator that I have 2 e to the x's. Both terms up here have an e to the x. And so what I can do is I can bring that out in front. So I limit as the h approaches 0 of e to the x times what's left over is e to the h minus 1 over h. And I can even, since h is what's approaching 0 and x is not a function on h, I can actually bring this out to the front and have e to the x multiplied by the limit as h approaches 0 of e to the h minus 1 over h. Now, finally, what I can see is this here is actually equal to 1, this portion. If I were to look at the graph of e to the x minus 1 over x, that's going to look like this. Of course, undefined when x is 0. But you can see from both sides is approaching 1. So this limit's equal to 1, which means my derivative is equal to e to the x. Now in our first example, a lot of students have trouble with this, taking the derivative of e to the x because it's so simple, pretty much. So let me find the equation of this line tangent. The first thing we're going to find is the point. And in order to find the point, I just evaluate y on 1, and I get e to the 1 squared. 1 squared is 1. E to the first is e. So my point is 1e. Now the part that confuses some people, especially the first time they deal with it. So I need to find the derivative of y with respect to x. This is chain rule. The outer function is e to a power, so that's going to still be e to that same power. I don't change anything when I have e to this power. But after chain rule, the inner function is this x squared, so I multiply this by 2x. And I personally prefer to write this as 2x e to the x squared, but because multiplication is commutative, they're equivalent. So I always write it this way, but you can change these terms and still be correct. Now I need the slope actually evaluated at 1, so I'll evaluate dy dx when x equals 1, and that's going to be 2 times 1, e to the 1 squared, which will be 2e. And from that, I can get my equation of the tangent line, which will be y equals 2e x minus 1 plus e. Second example. In this one, I'm going to take a first and second derivative, and instead of having a chain rule where e to the x is the outer function, here I have a chain rule where e to the x is the inner function. So for the first derivative, I take the derivative of the outer function, so the derivative of sine is cosine. I leave the inner function unchanged, and then I multiply by the derivative of the inner function. The derivative of e to the x is just e to the x. Now for the second derivative, I have to be a little careful, because I actually have product rule, the product of these two functions, and chain rule. So I'll do product rule first. Now remember, the derivative with respect to x of f times g will be g times f prime plus f times g prime. And so for this, I will have e to the x multiplied by the derivative of this, which will be negative sine of e to the x times the derivative of the inner function, which is e to the x. Then I have a plus this times the derivative of that, so cosine of e to the x times e to the x. And I can clean this up a little bit. So I have e to the x times e to the x, that's e to the 2x. I have this negative, and I have a sine of e to the x. Plus, and I guess e to the x in front of here. I guess I don't really have any hard and fast rules for what order I like to write things in, but I do like to have this e to the x before cosine. I guess I like to have the trig functions at the end. And so, here's our answer. Negative e to the 2x, sine of e to the x, plus e to the x cosine e to the x. Alright, I hope this helped out. Feel free to comment below if you do have any questions.